Assalamualaikum. So what we are going to do, we will still on the lecture 18, EE341. So we talked about impact of negative feedback, and we saw different type of amplifier. Now what we want to talk is basically in a negative feedback or in a feedback system. We mentioned about sensing, where we sense the signal but what's happening to that one, and then we return the signal, meaning we give a feedback sort of stuff. Return technique. So how we use these techniques in a circuit, we will see a little bit. Okay. So this is again one, and this is again section 12.4 of fundamental of microelectronics. So if we want to talk about in a feedback system, we said, okay, we have a feedback system A, we have some input X, we have some output Y, and that's a feed forward system. But for a feedback, we want to sense this output, okay, with some mechanism, and then we do some system. If we want to amplify, we want to put some gain, and then we want to return it, subtract, add the signal. So we're going to talk about this thing, which is a return technique, and the sensing thing, how we are going to sense this in a real signal. But before moving forward, we need to see what we want to do. We are sensing signal and returning signal or what? Here, what we can have either a voltage or a current. Okay, now we just see the four types, so we know that we can have either a voltage output or a current output. Same thing. When we want to feed back the circuit, returning the circuit, the input signal can be either a voltage or a current. So we can have all four combinations, which we just discussed about the current amplification, the voltage amplification, the transconductance, and the transimpedance can be there. So our sense and return can have all these four combinations. And if we just want to talk about voltage, we can just see something like this. This is, for example, a box, a system, and how we are sensing this voltage. How we normally sense a voltage. If you have a system, any black box, and we know its output is voltage, how you sense that output? How you do those things? A simple voltmeter, right? So you plug a voltmeter, okay, and measure, like, okay, bring the potential, for example, and you measure with a voltmeter. What voltmeter do? Parallel to the circuit, whatever the polarity parallel to the circuit, we want to measure the voltage. Okay, and what's happened with the voltmeter? That we have a device in which ultimately we have an input impedance which is infinite. Rin is very much high, input impedance is infinite, so that it don't load the circuit, go up to circuit configuration ko kharab na kare. So that's one of the main things. Same thing we want to have in our feedback system jo hum logon ne upar banaya hua. Let me just map the same thing. Okay, we have A0, which is a feed forward system, okay, which is having some voltage. At this moment, I'm just giving a polarity VO, okay, or V out kar dete hain isko. And we have some feedback system, okay. Feedback system kya hai? तो जो feedback system की polarity होगी, parallel में लगाऊंगा पहली चीज, इसकी जो polarity input impedance होगी, that should be equal to infinite. और in ideal world, जिस तरह हम जब भी बात infinite की करेंगे, this means I'm talking in terms of ideal world. So इसको circuit में किस तरह कर सकते हैं मैप? We can have A0, we have something, we have V in, positive पे आ रहा है, we have V out. If we have V out coming here, we can have some feedback, which you just saw. R1, R2, okay? And this is the feedback voltage, which we are going, VF. So we talk at this moment about this thing, sensing the voltage. So we are sensing this voltage that, okay, there is some voltage which is going or which is basically coming from an output. So we are sensing this voltage at the moment. ठीक है? So we can, और ये किस तरह कर रहे हैं? How we are doing this thing? So here our output is ultimately being divided based on the ratio of R1 and R2, or it's a voltage division, which is basically R2 divided by R1 plus R2. So this is in reality K for us. Okay, so this factor is a factor K. And also we want this R1 and R2 to be of very much high value, high resistance value. That R1 and R2, both of them should be very much high. Why? So that they don't load the circuit. We want it should be infinite. So R1 and R2 should be of very much high value. That's what we want. That's what we talk about the voltage. And what about the current? For the current scenario, we normally, how we measure the current? Using an ammeter. So if we have a circuit, let's say this is a resistor circuit. So how we measure the current? So if this is a circuit and somebody tell you measure this current I out, you said, okay, you will put a small resistance here, or you'll put a, this point, you'll put an ammeter and you'll measure the resistance, ammeter. Okay. In reality, what you put a very much small resistance here, and this current flow through very much small resistance, and you measure this potential. And by measuring this potential, you can find the current. So V, this is a V divided by very much small resistance, small, that will tell you the current. And it should be very much small, so don't affect the actual resistance of the circuit. So in this case, you measure the ultimately the current of a simple system. So now let's talk about some overall circuit, how we can in reality do the things, or how we can do the, at this moment we talk about the sensing thing, how we can do the return stuff. So for return, we need to add or subtract. यही करना पड़ेगा ना हमें, या तो subtract करेंगे या add करेंगे voltage को या current को. So let's talk about the voltage thing. If we have a voltage, how we are going to add or subtract? So voltage add and subtract, all of us know we cannot put in parallel, we have to put in series. So this is V1, this is V2. So my ultimate potential will be what? अगर मैं यहाँ से यहाँ देखूं, V out है, V out will be V1 minus V2. ऐसा ही हो जाएगा. So we can do the addition or subtraction, whatever the way we want, based on just adding them in the series. We can definitely do this thing. अब इसको हम लोग circuit में किस तरह implement करेंगे? Simple diff pair, which we already have seen, right? क्या होता था diff pair में? ये V in था, दूसरी साइड पे अगर मैं वो feedback वाली voltage अभी हम लोगों ने last configuration में decide की थी, ये A0 था, gain था कोई, ये हम लोगों ने कहा था ना R1 है, R2 है, this point is VF. If we feed this VF here, what's going to happen? We are ultimately having a diff pair, and here Vn minus Vf. जिस तरह आपको याद होगा differential pair में we are applying the difference of these two potentials, so we can have directly a voltage subtraction can be done. So we can sense here and we can return here. हम ये काम आराम से कर सकते हैं. We will see in the circuits. Just at this moment I'm giving you a little bit abstract overview for the overall configuration. Same thing for the current. Current में हम लोग क्या करते हैं? In the current configuration, we join them in the parallel. This is I1 and this is I2. The net current by this direction we can identify is I1 minus I2 or whatever, I1 plus I2. We can have an I net based on sign of these two. We can do this thing. So currents को हम लोग parallel में करते हैं, voltages को हम लोग series में करते हैं. And same thing we can apply for our circuits in this configuration. So for example, if I want to draw one circuit for a current one, again an amplifier जिसमें एक current जा रहा है, I. This is a difference is going here. This is I out or IE. Ultimately difference है. किस तरह difference है? We have a current amplifier here, which is working. Some current is going feedback and something we're feeding. I in. So IE क्या होगा? I in minus IF. So some current is going at this point and we are feeding current here. So these two are in parallel, same thing as this analogy. And ultimately IE is being forwarded to this one. But the whole idea about this one, we can add voltages, subtract voltages in series, add currents, subtract currents in parallel based on their polarity. So we can do this thing and we can ultimately find whatever we want. So we can add and subtract, so we can sense and we can return the signal. So now what we want to apply these things to a powerful concept that is basically the polarity of the feedback. At this moment, we just identify the different topologies, but now we want to apply these things to the polarity of feedback. What is the polarity of feedback? Is it a negative feedback? Is it a positive feedback? We know that we have seen that, okay, the system previously was a negative feedback and easily we identified with a negative sign. Like we have this thing, we have Y output, we have something going K here, and this is summer, but here negative sign, positive sign. This means a negative feedback. But in the circuits, it's not that much clear. We need to identify how. What is the way of identifying? That is basically we apply some signal, we see the effect on the feed forward path, we see its effect on the feedback path and see what it is doing. Is it enhancing? If it's enhancing, this means it's a positive feedback. If it's not enhancing, if it's trying to decrease it, this means it's a negative feedback. Meaning I apply a signal, which is, let's say, positive signal here. It should increase. I will see the effect here, increasing here. I see the effect here, it's increasing here. But if it's increasing at this point, what's doing? It's a negative one. The net impact at this point will be what? It will try to decrease the same thing. This means it's a negative feedback. But if I apply a signal, it increase here, it decrease somehow here, and what will happen? The overall signal will go up. So if it support the overall effect of this signal, this means it's a positive feedback. If it reduces the effect of this signal, this means it's a negative feedback. So let's apply this thing to the any circuits and then we can analyze these things. But the procedure, let me write those points, which are again very much important for our identification. So assume, first of all, the first thing is that assume input signal goes up or down. Something you have to as a starting point. Either up करेंगे, down करेंगे, and you want to follow its behavior. So follow the change through the feed forward and feedback. So दोनों से जो feed forward and okay, we have both. So we'll follow its path through the feed forward and feedback path. Once we have followed that, then we are going to see whether the return quantity, जो return signal है, that is our return quantity or signal, whatever the way you want, return quantity opposes. That's very much critical. It should be opposing the overall trend or no. Okay? Opposes the original effect. So यहाँ हम लोगों ने original effect की बात करनी है. Effect or no. So अगर वो oppose करेगा, this means a negative feedback. नहीं oppose करेगा, positive feedback. ठीक है? Let me just identify with the help of some circuits. So, and again, you need to pay explicit attention to these points. I will take in the next page, so it's more like a clear. Let me draw the circuit. So it's basically same your differential with active load, fully differential with active load circuit. डायोड को नेगेटिव है, लोड आ गया आपके पास। ठीक है, this is M1, M2, M4 and M3, and this is a fully differential network. ISS हो गया, and here this is your output. So here we have some feedback path which is going to this node. And again, R1 and R2 are pretty much bigger values, so they don't load the system. Okay, so this is the overall configuration, and we are basically asked to determine, let's say this is a, we are asked to determine the polarity of this system. So first thing, we need to find the feed forward path. What is the feed forward path? I will use this blue color. So feed forward path is this thing, for example, this one, and this one. And V after the effect of Vx is going to be feedback path. So this is the blue one, is a feed forward path. So let's see what's happened. If V in increases, what's going to happen? If my V in goes up, there's a current flowing through this point, ID1. So the ID1 will go up also. ठीक है? Voltage increase करेगी VGS की वजह से, ID1 will increase. Well and good. If my ID1 increases, what's going to happen with this ID2? If ID1 increases, what's going to happen with ID2? जो यहाँ flow कर रहा है ID2. Can anyone say anything? It's a differential pair. ID1 increases. This means, in the one sense, ID2 will decrease by the same amount because the net overall current will remain same. So this means ID1 will increase, ID2 will go down. If ID2 will go down, what will happen with V out? I will see with the multiple configurations, but if ID2 goes down, what will happen with the, I'm writing here, what will happen with V out? So this ID is multiplied by this resistor. So V out, if we want to write, is VDD minus some resistance, which is followed by this R04 I'm writing, times ID2. If ID2 goes down, what will happen with this V out? This V out will go up, right? So V out will go up. If V out will go up, what will happen with Vx? Vx will also go up. Okay, so you can see this thing, this table, which is just made here for you. V in goes up, ID1 goes up, ID2 goes down, V out goes up, Vx goes up. So Vx out goes up, Vx goes up. Okay, up now Vx is VGS here, VG here. VG goes up, what's going to happen? Ultimately, because of VG going up, what will happen with ID2? ID2, let me make a blue color. Now this is a feed forward path. Now let's see the feedback path. I'm using green color. Now in the feedback path, if Vx goes up, use the same. That's very much important. Now you need to see Vx goes up. This is the feedback path again. What will happen with ID2? ID2 will go up, opposite. ID2 will go up. What will happen with ID1? Goes down. Opposing this change, what will happen with V in? We don't even have to see V in, you will also have to reverse back. So V in was increased initially in the feed forward path, ID1 was increased, ID2 was decreased, V out increased, Vx increased, but in the feedback path, because of Vx increasing, the ID2 was increased, and because of ID2 increasing, ID1 was decreased. So Vn intending to increase ID1, but because of the feedback, it's reducing the value of ID1. That's why it's a negative feedback. वही जो हम लोगों ने बात की थी, the net impact is opposing or supporting. In this case, it's opposing. Okay, Vn was intending to increase this thing. You can see the opposite way. Let me write the things first. Is a feed forward, and the green one is a feedback. Let's see the opposite way. V in goes down. If V in goes down, what will happen with ID1? ID1 will go down. What will happen with ID2? ID2 will go up. If ID2 goes up, what will happen with V out? V out will go down. What will happen with Vx? Vx will go down. If Vx goes down in a feedback path, Vx goes down, what will happen with ID2? It will go down. What will happen with ID2, ID1? It will go up. So again, opposite, negative feedback. This system is a negative feedback system, so we can analyze this one. So there is a feedback, and the feedback is negative feedback. This is the common we apply. Okay? So make sure this is very much powerful, and it's applying all the things which you have learned by this time. You can apply the same thing. You can, in any way, you can form out this circuit. Let's apply to another example. Yeah. So let's see another example. We have in here, we have M1, we have here M2, RD2, we have here V out, we have here RF1, and we have RF2. Again, RF1 and RF2 should be of very much high value. Here it's not grounded, it's connected. Okay, so we are having a feedback which is going to this point. Okay, right? So I guess that's all. And this node is known as Vx. Same thing. Let's apply again. V in goes up. If the V in goes up, what's going to happen to this current which is moving here? ID1. ID1. ID1 will go up. Okay, V in goes up, current will increase. What will happen with the potential VA? तो ये point है VA. VA के साथ क्या होगा? If ID1 is going up, VA will goes down. It's clear, VA will goes down. If VA will go down, what will happen with the V out? So if VA goes down, what will happen with V out? We can see in multiple ways. VA is going down. It's a common source amplifier. V out will go up. Inverting behavior. Or VA goes down. What will happen with the current? Current will go down. And if the current is going down here, what will happen with the V out? V out will again go up. So VA goes down, V out will go up. V out will go up. What will happen with Vx? Vx will go up. Vx goes up. What will happen here? So here it's a Vx is going up, and ID1 is depending upon what? VGS. What is VG? V in minus Vx. V in was going up, and now Vx is going up. So ultimately, VGS is depending upon it, is directly proportional to. So what will happen to this one? Vx is reducing. So ID1 will goes down. Okay? So now what's going to happen? You can see as Vx will go up, this potential goes up. ID1 इसको green color में कर देते हैं. As it goes up in a feedback, ID1 goes down. So again opposite. Again a negative feedback. Let me write it again for you. So feedback V in 1 goes up. Just make sure to identify these things. ID1 goes up. As ID1 goes up, the VA goes down. Right? VA potential goes down, the V out goes up, Vx goes up. As the Vx goes up, now this is in the feedback path. What's happening? Vx will make ID1 plus. You can again see negative feedback. So make sure to do these things yourself, because this is again a simple but a powerful concept, and that will make you identify. You can see in any way. You have to see the current. You can see the current. You have to apply the common source, common gate configurations, apply those things. But you need to see the polarity. Voltage increase, what's happening with the current or what's happening with the voltage. Okay, let's do the opposite way. V in is going down here. V in is going down. V in reduces. What will happen with ID1? ID1 will goes down. What will happen with VA? VA will go up. What will happen with V out? V out will go down. What will happen with Vx? Vx will go down. In the feedback path, Vx goes down. VGS, S is being reduced. VGS will increase. What will happen with ID1? Will increase. Negative feedback again. Okay. So that's again try to identify what main thing you can use for this one. That first thing, VGS is directly proportional to ID. Okay. Since we are in saturation, we're talking in saturation, VGS is directly proportional to IG. Meaning if VG increases, ID increases. Okay. If VGS increases, ID increases. If VS increases, ID decreases. Make sure, remember this thing is the VGS, not VS. So VG increases, ID will increase. VGS overall increase, ID will increase. VS increase, ID decrease. Make sure this thing. Second thing, which you need to identify also, if you have this configuration, and this is a V out, if ID is flowing through here, and this is a VDD, if ID increases, your V out will decrease. You can see ID increase, V out will decrease in any cases. V out is VDD minus IDRD. So anyway, you can see. Third thing which you can identify also is if V in increases, for example, here the VA increases, what will happen with V out? That will go down because it's a common source configuration. So anyway, you can tackle the circuit, but make sure have your own systematic analysis and identify the topology. Okay, let's see another example, and then you can just make sure you do a couple of more on your own and bring it, because we will give the similar in a next quiz which you are going to have soon. So let me draw the circuit. So we have another circuit. M1, V out. So we have, sorry, this line. M2. This is a node X, for example. Input current, you have something RD, and this is VDD. Okay. So let's start again. I in increases. Let's say I in goes up. What will happen to the potential at Vx? Means if we are having a current which is flowing through here and there's some impedance in here, so Vx potential of voltage will go up. If Vx goes up, what will happen with the ID1? Again, VG gate we are applying, VGS goes up, ID1, which is the current here, will go up. ID1 will go up. What will happen with this V out? V out will go down. We just talked about these things. So V out will go down. As V out will go down, this VGS goes down, this ID2 will goes down. If this ID2 is going down, what's going to happen to the Vx? Just again see analytically, this ID2 is going down, this node Vx will go up again. So this is up. Making ID2 down, Vx is going again high. So it's a positive feedback. I will just write it and then let's do it again. I in goes up, Vx goes up. Why Vx goes up? Because there is some resistance multiplied by that current, it's going up. Vx goes up, ID1 goes up, okay? Because it's VGS, So ID1 goes up. Now it's V out because V out minus ID1 goes up. V out will go down. V out goes down. VGS2 basically goes down. VGS2 goes down. ID2 goes down. Okay. Now feedback path. ID2 goes down. You can see multiple ways. ID2 goes down. There's a current which is being divided into these two. So ID2 goes down. Ultimately, the potential Vx will goes up. Okay. The potential at this point, somebody is feeding the current here. So it will go up at that node. Less current is going on this ID2 side. Or you can see this simple configuration. Previously, 1 microamp was going here. Now it's 0.5 microamps going. So 0.5 is going somewhere. That 0.5 is going in this point multiplied by that resistance. So that voltage even further goes up. That's why if Vx increasing and Vx increasing, it's well and good. Let's see the opposite scenario. I in goes down. What will happen with Vx? Goes down. What will happen with ID1? Goes down. What will happen with V out? Goes up. What will happen with ID2? Goes up. Feedback path. ID2 goes up. So now the potential of Vx has to drop. Again, a positive feedback. So this configuration is a positive feedback. And as we mentioned previously, we use positive feedback in analog circuits or in digital circuits, mainly for an oscillator development or for the creation of a latches, memories where we want to hold the value for a longer period. So just make sure, do this thing, explicitly revise these examples. First of all, do these 3 examples which we did in the class, and also go in the book. There are a couple of solved examples and there's a problem. So do those problems and clarify these negative positive feedback concept. That's polarity is very much stronger for the next section which you want to talk. And also in journal, it gives you a whole idea how you analyze the circuit, that okay, how the circuit is going from input and output and how the feedback is playing its role. So make sure, make these things strengthen before the next lecture. And come into the office hours if you have any concern, queries. We normally are available on office hours. We turn it on. Even if you that time doesn't suit you, you can come on any other slots or email us. We will try to accommodate you. Right. Thank you very much for your attention.